Lesson 11.2, Inference about two population means that are dependent samples. If we look at our overview sheet, we have population mean on the left-hand side, so that's quantitative data, two populations, and that are dependents. So we're going to be filling in this number 16 and 17 from this lesson. Here are the criteria for both dependent and independent. The objectives for this lesson is to test hypotheses for a population mean from a matched pair's data and construct and interpret confidence intervals about a population mean difference of matched pairs design. The criteria for testing hypotheses regarding the difference between two population means for dependent samples is 1. The sample is obtained by simple random sampling or the data result from a matched pairs design experiment. 2. The sample data are matched pairs, so they're dependent. 3, they have to be normally distributed, so you need to either check that on your calculator or n it needs to be greater than or equal to 30 for it to be approximately normally distributed because of the central limit theorem. And then the fourth, the independence requirement, so n needs to be less than or equal to 5% of the population. The 5 steps for testing a hypothesis regarding the difference between two population means for dependent samples. Step 1 is to determine the null and alternative hypotheses. So pretty much everything is going to stay the same. The only thing that's going to change are these symbols here, not equal to, less than, or greater than. You're going to have mu of d and 0 always in these locations. Note that mu sub d is the population mean difference of the matched pairs data. Step 2 is to select a level of confidence, alpha, depending on the seriousness of making a type 1 error. Step 3 is use number 16. You can check for normality and no outliers if n is less than 30 on your calculator sheet to obtain the p-value and test statistic. And if p-value is less than alpha, we reject the null hypothesis. And if the p-value is greater than alpha, we do not reject the null hypothesis. And then we can state the conclusion. Okay, before we move on to the next page, let's look at mu sub d equaling 0. How exactly did they get that? So before proportions, we worked with the proportion equaling the other proportion. So you can do that with the means as well. If you subtracted over mu sub 2 on both sides, this one would cancel, and you'd be left with mu sub 2 minus mu sub 1 equaling 0. And then the alternative, let's just do the less than. Again, if you subtract mu 2 over, your alternative is mu sub 1. Oh, I'm sorry, this should be 1 minus 2. Minus mu sub 2 is less than 0. So here, this d just means or represents this mu difference. Instead of writing out mu sub 1 minus mu sub 2, it's written as mu sub d. So just know that it can be written this way as well. It may be helpful for when you put information into your calculator. Let's look at an example. Professor Andy Neal measured the time in seconds required to catch a falling meter stick for 12 randomly selected students' dominant hand and non-dominant hand. Professor Neal wants to know if the reaction time in an individual's dominant hand is less than the reaction time in his or her non-dominant hand. Coin flip is used to determine whether reaction time is measured using the dominant or non-dominant hand. Connect the test set at the alpha equaling 0.05 level of significance. So the first criteria or condition was to be random. We're flipping a coin, so that's random. And it is a matched pairs design because we have your non-dominant hand, and then your dominant hand, and then your non-dominant hand. Second condition needs to be dependent. It is dependent. Then we need to, step 3, differences need to be normally distributed. Without outliers. So what we're going to do is we need to determine which one's going to be in list 1 and list 2. So we need mu sub 1, whatever is on the left hand side. So if you look at here carefully, the question, it says, wants to know if the individual's dominant hand is less than the non-dominant hand. So this would be mu 1, this would be mu 2, and this is less than. So the dominant is mu 1, non-dominant is mu sub 2. So luckily this one works out nicely where you can put mu sub 1 in list 1, mu sub 2 in list 2. If this was mu sub 1, you'd put it in list 1. Okay, I'm going to pause the video and put these into my calculator. Alright, I now have the data into the list. Right now we're going to be just checking to see if it's normally distributed without outliers. Since n is 12, it's not greater than or equal to 30, so we have to make sure it's normally distributed. So you can follow number 16. So for normality, go to second, y equals, before we do that, we need to finish this step. So go up to list 3, type in L1 minus L2, and then hit enter. It's going to calculate all the differences for you. Now we want to make sure the differences are normally distributed without outliers. So go to second y equals, the last plot, and then change that list to list 3, graph, zoom, number 9. This looks fairly like it's in a straight line, so we can say it's approximately normal. If I gave you a correlation, you should be able to find the critical value. If the correlation is greater than a critical value, that means it's normally distributed. And then outliers. You can see we have no dots outside of this plot. So it looks like we have no outliers. So that is good to go. And then step 4, the sample size is no more than 5% of the population. Okay, we determined the criteria. What we should be doing for all of these is asking yourself, quantitative or qualitative? Is this information quantitative or qualitative? It is quantitative because we have numbers here. So quantitative. Do we have one population or two populations? 1, 2. So we have two populations. Is it independent or dependent? Okay. Dependent. It's a matched pair. So if you can figure out those things, you can go to your overview sheet, go to quantitative, go to two populations that are dependent. And this should tell you to use 16 and 17 on your calculator sheet, depending if you want the hypothesis test or confidence interval. So I would try and get the habit of doing that consistently. Okay, step 1. The null and alternative hypothesis. The null is mu sub d equals 0. Alternative is mu sub d. And it is going to be less than. Step 2, alpha is equal to 0.05. Step 3, Now we need to calculate that test statistic. Stats test number 2. We have data. It is in list 3. Mu sub 0 needs to be 0. Frequency is 1. And we're doing less than. And calculate. So our test statistic is negative 2.8. P-value is 0.009. Step 4, compare your p-value to your alpha. How does that compare to alpha? It is less than alpha. When it is less than alpha, you reject the null hypothesis. So, going with the alternative. Step 5, state the conclusion. We can say there is sufficient evidence at the alpha equaling 0.05 level of significance to conclude that the reaction time in the dominant hand is less than the reaction time in the non-dominant hand. The p-value of 0.009 means that if the null hypothesis, which is the mean difference is 0, is true, we expect a sample mean of negative 0.0132 seconds or lower in about 9 out of 1,000 repetitions of this experiment. The results we obtain are not consistent with the assumption that the mean difference in reaction time between the dominant and non-dominant hand is 0 seconds. Simply put, because the p-value is less than the level of significance, Professor Neal rejects the null hypothesis.